The problem statement is we need to plan the total lightning cost for the next 2 years, and the lightning cost includes the cost of the bulb as well as the cost of the electricity. And in the market, there are three types of bulbs available: regular bulb, and it costs C1. It has a warranty of M1 hours and a running cost of R1 per hour. In the same way, the second type is CFL bulbs. The cost is C2, warranty is M2 hours, and the running cost is R2 per hour. And the third type is LED bulbs. The cost is C3, warranty is M3 hours, and the running cost is R3 per hour. We also have two constraints regarding the cost as well as the running cost. For the cost, the regular bulbs cost less than the CFL bulbs, and the CFL bulbs cost less than the LED bulbs. In the same way, R1 running cost for regular bulbs is more than the CFL bulbs, and for the CFL bulbs, the running cost is more than the LED bulbs. The plan is to install one bulb in the kitchen, two bulbs in 3 rooms. So in each room we need two bulbs. We have 3 rooms, so total 6 bulbs, and one bulb in the bathroom. For the bulb in the kitchen, we need it should work for H1 hours per day, and all 6 bulbs in 3 rooms. The two bulbs in first room should work for H2 hours per day. Two bulbs in second room should work for H3 hours per day. Two bulbs in third room should work for H4 hours per day. And the bulb in the bathroom should work for H5 hours per day. We need to prepare the budget, assuming that it should the bulb last till the warranty period, and after the warranty period it will not work. So based on all the above requirements, we need to plan the least cost over 2 years. So we also have one more constraint, that is if a warranty expires for a bulb, the bulb should be replaced, and they also given that it should not be replaced by the original one. We can replace it by anyone. So if for suppose they also give an example. So if a bulb has a warranty of 1400 hours and we need 1460 hours to be done. So then for the remaining 60 hours, we don't need the same bulb to be installed as the warranty. If the warranty is 1400 hours, obviously the cost will be more. And we can go for different bulb which has an initial less cost compared to this bulb, and we can also with the lower warranty also. So we just need 60 hours. If any bulb is having 60 hours warranty with the less cost, we can use them. So in that way we can have least cost. That is the overall problem statement. Coming to the input format, first 3 lines contains the fixed cost, warranty and running cost. So that is C1, M1 and R1 for 3 bulbs. So for regular bulb, CFL bulb and for LED bulb. And the next 5 lines contains the number of hours the bulb is using in a particular room. So we can see in this sample output, cost of a regular bulb is 50, warranty is 1500 hours and the running cost is 16. For CFL bulb, the cost is 100 and the warranty period is 8000 hours and the running cost is 14 hours per day. And for LED bulb, the cost is 400 and its warranty is 25,000 hours. In the same way, the running cost is 1 hour per day. Sorry, its running cost is 1 per hour. And for CFL bulbs, it's 14 per hour, and for regular bulbs, it's 16 per hour. And the next 5 lines contains the number of hours. Next 5 lines contains number of hours the bulb is using in a room. So in a kitchen, it is 1 hour. In the room 1, it's 2 hours. In room 2, it's 8 hours. In room 3, it's 14 hours. And in bathroom, it's 2 hours. We need to calculate the least cost over these requirements. So the code is this, and once we will run this code, and then I will explain it line by line. Basically, the problem is about calculating the least cost. And for least cost, we can use DT for better time complexities. So we are using scanner for scanning all the data given by the all the data that we required. So C1, M1 and R1 are the buying cost, warranty hours and running cost per hours for regular bulbs. In the same way, C2, M2 and R2 are the running cost hours and running cost for CFL bulbs. In the same way, C3, M3 and R3 are for the LED bulbs. So we are creating an array of size 5 to store the daily usage hours for given a kitchen, room 1, room 2, room 3 and bathroom. And total we are calculating for 2 years, that is 730 days. We are making it as final so that we are not going to change this anywhere in the program. We need another array to store total hours each bulb must work over 2 years. So we multiply each daily hour value by 730. So number of days is 730 and we are multiplying each daily hour value so that we can find the total number of hours that bulb will be used in 2 years. So this integer array is the number of bulbs at each place. So in kitchen it's 1, in room 1 it's 2, in room 2 it's 2 and room 3 it's 2 and in bathroom it's 1. So we are finding the maximum hours. So we will find the maximum hours so that we can use it for the size of a DP. So these two statements are we are finding the largest number of hours from this total array. If the largest value is 0, so no hours are required, we simply print 0 and we will return from the program. And we are storing the bulb parameters in an array. So cost, we are storing the cost in CS array, warranty in MS array and the running cost in RS array. And we are defining a very large number. So it's an initial impossible cost. And we are also defining a DP array. So in this DP array, DP of H defines the minimum cost to get exact H hours of light. So if we want H hours of light, we will simply take the DP of H value, and we are initially filling the DP array with this infinity value, and we are taking the DP of 0 as 0, as the cost of lightning for 0 hours is 0, so we are initializing it 0. So the cost of lightning at 0 hours is 0. We are initializing the DP of 0 as 0. So we go R by R from 1 to max of H. So the maximum number of hours, we are going from 1 to maximum number of hours. So and we try to compute the minimum cost for each hour. So for each hour, we need to calculate the 3 bulbs value. We will take each bulb and we will calculate the value for each bulb, and the cheapest will be calculated. So in TEM and long C and long R, we extract warranty cost and running cost of the current bulb type. So if the value of T is 0, so we are getting the warranty cost and running cost for the regular bulb. In the same way for T value as 1 and T value as 2. And so the SEM indicates the bulb can cover at most M hours. So it can cover up to M hours. If the M value is 10, so it can cover up to 10 hours. So it can also cover up to 5 hours or else 10 hours. So this is the maximum value that a bulb can cover. So if the H is 1, so we will subtract it from, we'll subtract this and we'll keep it as preview. If preview is less than 0, then preview will be obviously equals to 0. So we will also calculate the number of hours this bulb will actually work, and what is the previous cost, and what is the running cost. Running cost is nothing but the running cost per hours and the number of hours the bulb is used. And the total cost will be previous cost, running cost, and the cost of the bulb. We'll take the total cost. And the best is nothing but, we also initialize the best value as infinity, and we will calculate both the minimum value as well as the, we will take the minimum value from best and the total cost. In the same way, it will be used for total three bulbs, for regular, CFL, and for LED bulbs. And the minimum value from three bulbs will be taken for the best. And after returning from this loop, we will assign the dp of H value as the best. In the same way, we will calculate all the dp value. We will fill all the dp array from H is equals to 1 to H. H value as max H. And the final cost is calculated in this array. So for the final cost, we will calculate the dp of totals of I, and this gives the cost of one bulb, and we are going to multiply the number of bulbs in that location, and we are adding that to the answer, and finally answer is printed.